These are called, what we have seen so far is addition of pole, addition of zero. Addition of zero, addition of poles are called compensation. Sometimes in the examination, they will ask in terms of compensation. Adding some zeros and poles to the original system is called compensation. Adding some zeros and poles to the original system to improve its performance is known as compensation. First compensation is proportional compensation. Proportional compensation. Already this we have seen, but anyhow, once again we will see that. Proportional compensation. This is R of S. This box is left for compensation. Original system is G of S. Original system is G of S. This is a closed loop system. This is closed loop system. If I put K, that is amplifier here, that is called proportional compensation. Let us assume that the original system is S square plus any doubt? Any doubt? Oh, you want to see the words. Dynamic performance. Adding some zeros and poles, dynamic performance. Yes, overshoot is increased. Race time is reduced. These are all dynamic performance. Dynamic performance. Change in TR, change in overshoot. These are all dynamic performance. We can modify the dynamic performance simply by adding poles and zeros. By adding K, what will happen to the system that we'll see now? 1 upon S square. Suppose the original system G of S equal to 1 upon S multiplied by S plus 1. Original system is 1 upon S multiplied by S plus 1. After adding that K, G of S compensated becomes what? 1 upon K upon S multiplied by S plus 1. Am I correct or not? K upon S multiplied by S plus 1. What is the closed loop? This is compensated. What is closed loop transfer function? T of S equal to G of S upon 1 plus G of S. H of S equal to 1. Unity feedback system. Therefore, this G of S, if we substitute K upon S multiplied by S plus 1, what happens? K upon S multiplied by S plus 1 whole divided by 1 plus K upon S multiplied by S plus 1, that is equal to K upon S multiplied by S plus 1 plus K. Am I correct or not? Where you added K? You added K in the numerator. In closed loop, it becomes part of denominator. In closed loop, it becomes part of denominator. What is the roots of the denominator? What is the roots of denominator? K upon S square plus S plus K. What are the roots of the denominator? Minus B plus or minus square root of B square minus 4AC. 4AC. So if you vary K, you can vary the poles. If you vary K, you can vary the poles. Pole will move. If you vary K, pole will move. Am I correct or not? So actually you are adding a increasing the amplifier gain, but pole is moving. Sometimes it may go to the right hand side also. Sometimes it may go to right hand side also. Suppose you added 1K, that moves the pole to the right hand side, means system becomes what? Unstable. System becomes unstable. That's why while adding gain, we should be very careful if it is a closed loop system. In open loop system, no problem. If it is closed loop system, the K becomes part of denominator. Denominator decides the poles. Denominator decides the poles. If the poles are moving, depends upon the value of K. Depends upon the value of K, the poles are moving. Because the poles P1, P2 equal to what? Minus 1 plus or minus square root of 1 minus 4K. Depends upon the value of K, you will get different poles. If it is second order system, no problem. If from third order onwards, you will study later, but I am telling just the next chapter, you will study in detail about that. From third order system, if you increase K, the pole will move towards right hand side. So let us take one example. Here, 3 poles are there. I am having a system which has 3 poles are there. If I increase K in closed loop, this pole will move to the left hand side. This pole will move like this. This pole will move like this. As K increases, at one particular value of K, it is exactly on the j omega axis. And one particular value of K is exactly on the j omega. It means system will oscillate. If you further increase the pole to the right hand side, further increase pole right hand side. An amplifier has negative feedback. I have studied amplifiers having negative feedback. In electronics, you studied amplifiers have negative feedback. There, if you increase the gain beyond a certain value, it starts oscillating. It will start oscillating. That's why we should be very much careful about how much gain we are giving. How much gain we are giving. From third order onwards, if any increase in K may drive the system to the right hand side, drive the poles to the right hand side. In other words, may drive the system to unstable. From third order onwards. That we'll see later. For the system above second order, the increase in steady state gain drives the system towards instability. So increase of K decreases the steady state error to some extent. How? Increase of K reduces steady state error. What is Kp? I'll finish. What is Kp? Kp equal to limit S tends to 0, G of S. For type 0 system, it is K. It is K. Am I correct? What is steady state error? 1 by 1 plus K. If you increase K, what will happen? Steady state error will decrease. If you increase K, steady state error will decrease. Definitely. For a type 0 system. But if you increase beyond a certain value, the system becomes unstable. That's why when the steady state error becomes 0, 1 plus K should goes to infinity. If you increase K, steady state error will decrease further. But when it becomes 0, as K tends to infinity, steady state error becomes 0. But you cannot put K equal to infinity. But to reduce error, if you increase K beyond a certain value, the system may become unstable. The system may become unstable. Okay, that we will see later. Tomorrow we will see.